In this video, we're going to look at the distributive property of multiplication. First, we're going to look at what modeling the distributive property of multiplication would look like. So up on the board, I have a rectangle. The width of the rectangle is 5 units wide, and the length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units long. Now typically, to find the area inside the rectangle, we could go through and simply just count the squares that totally fill up the inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. However, that would take a long time to do, especially if the rectangle were very, very large. So instead, we would directly just multiply the width, 5, by the length, 13, in order to find the total number of squares that cover the entire surface. Thus, the unit of square units, whatever the unit may be. In this case, we haven't designated a particular unit. However, we could also break this problem down into a simpler way to figure out what 5 times 13 is in order to solve it mentally. We would take, in this case, the number 13 and decide how to break 13 down into a simpler way to think of it in order to multiply mentally. We would want to break it down into some number added to another number, and one of those numbers we would like it to end in a 0 because it's very simple to mentally multiply by numbers that end with 0. So we would think of 13 as being 10 plus 3. And of course 10 plus 3 is still 13. Now we haven't done anything to the 5 times in front of it. So this is still 5 times 13. It's just in a slightly different form. So, over on the model, we're going to demonstrate the length broken down into a length of 10 and then into a length of 3. So first, the length of 10 we're going to do at the top. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is going to be the larger of the two rectangles. So 10 times 5 is going to be 50. So that is going to be the area of this larger rectangle. So its area is 50 square units. Now for the smaller rectangle, it has a length of 3. 1, 2, 3. So there is our smaller rectangle, and we're going to fill in its area. So we have the 3 here. If this side over here is 5 units, then this side would also be 5 units. So we can see it a little bit better right here. So 5 times 3 would be 15. So this smaller rectangle has an area of 15 square units. So to get the area of the entire rectangle, we would just add the area of the smaller one, 50, plus the area, the bigger one, 50, plus the area of the smaller one, 15. So 15 plus 50 would give us a total area of 65 square units. My pen is wanting to connect together. Sorry about that. So now, this is what the model would look like over here. To look at the distributive property, it would look something similar to this. First, we multiplied the 5 times the length of 10. One thing that I always tell students to think about is the word distributive. In the word distributive, you have the word distribute. And when you distribute, you give. So we are going to be giving, in essence, the 5 times first to the 10. So the 5 times is given to the 10. This is going to be, in our model, the larger rectangle in red. Next, we give the 5 times to the 3. So we would give the 5 times to the 3, and that represents the smaller rectangle. Now the last thing that we did was we added both of them together, 50 plus 15. So we added the larger rectangle in red to the area of the smaller rectangle in green. So 5 times 10, that was our 50 in red. And the 5 times 3 was our green area, or the 15. So the 50 plus the 15 gave us an area of 65 total square units. And that's what we saw in the model. So the distributive property, in essence, is just a way to make a slightly more complicated multiplication problem a little bit easier to work out and break it down into simpler parts. In the model, that is pretty easy to see. Now, we can use that same idea with a rectangle that doesn't have all of the little squares filled in for us. The grid is invisible. It's not actually there. So we're going to use that idea in order to help us solve this mentally. So typically, to get the area of this rectangle, we would multiply 3 times 78. But let's break down the 78 into 70 plus 8. I'm picking that because 70 ends with a 0. It's going to be a lot easier to multiply mentally. So I have not done anything to the multiplication of the 3 times in front of it. Now I'm going to give or distribute the 3 times to the 70 first. Well, using mental multiplication, our patterns of 0, I can multiply 3 times 7, which is 21. And in this whole entire problem, 3 times 70, there is 1 0, so I can add 1 0 to the end. So 3 times 70 is 210. Next, I am going to give the 3 times to the 8. Well, 3 times 8 is 24. And remember back in our old model that we just saw previously, the first number represented the area of the larger part of the rectangle. The green represented the smaller part of the rectangle. And then, in order to get the area of the entire rectangle, we added the 2 numbers together. So, when we add the 2 numbers together, 210 plus 24, we get 234. And of course, in the area, that would be square units. So the entire area of this large rectangle would be 234 square units. Now, after looking at 2 models, let's just take any multiplication problem. So let's take and we're going to keep it very simple right now. Let's take 4 multiplied by 63. So if we wanted to multiply 4 times 63, we could break down the 63 into 60 plus 3. 60 ends with a 0. And put the 4 times in front of it. Here is where we use our distributive property. We distribute or give whatever is outside of the parentheses to each number inside of the parentheses. So the 4 times would be distributed or given to the 61st. Then the 4 times would be distributed or given to the 3. Separately, remember, think back to rectangles. This would be the larger, this would be the larger rectangle in red, and the green would be the smaller rectangle. And we add those two together. So we know in our order of operations that anything inside of parentheses, you work that out first. 4 times 6 is 24 with 1 0. So the product, 4 times 60 is 240. Then, in the other set of parentheses, 4 times 3 is 12. Now that we're done working out what's in parentheses, we can perform the operation in the middle. 240 plus 12, that would give you 252. So the product would be 252. If I did this in the traditional algorithm or the standard algorithm, I would use the commutative property and switch the order of the factors and put 63 on top as the multiplicand because it has the most digits, and put the 4 on the bottom as the multiplier. Then 4 times 3 is 12. We would put down our 2. We would carry our 1 over to the tens column. Then 4 times 6 is 24 plus the 1 we carried is 25. So you do end up with the same product. So this demonstrates that the distributive property is one way that you can mentally figure out a multiplication problem. Now I've used simple problems with single digits in it just to demonstrate how to do this. So hopefully this will help you, and there may be times where you really find the distributive property helpful with your math.